Respected guests, professors, and viewers, good morning from my side. I welcome you all in today's presentation that is regarding the paper Roadside Vertical Solar Wind Energy Tower. My name is Mirsad Shah and I am a graduate of DHS Ufa University. I have done my bachelor's from DHS Ufa University. I am currently enrolled at TU Dortmund University, Dortmund, Germany. The co-author of this paper is Dr. Jasem Uthman Al-Anjani. He is the assistant professor at Computer Science and Engineering Department of Yambu University College, Kingdom of Saudi Arabia. The email addresses of our respected profiles are listed below. You can reach out to us and discuss any of these queries that you may have at our email addresses below. The table of contents are listed below. We're gonna discuss the introduction, advantages, the research design, and working results, conclusion, and references. Please stay with us. So the introduction that I'm going to try and give you is if you have drove on a highway with no street lights, you know how tiresome it gets when there is absolutely nothing on the road. So road power generation is a recent technology that scientists or professors have been stressing upon, and this includes that you place a device on the road and that produces electricity and powers street lights or nearby charging stations. So a wind turbine, if placed near a road, it can absorb or it can convert the wasted kinetic energy that a vehicle produces. So if a vehicle is moving, it produces wind energy. As you may have noticed, if you stood beside a vehicle and a vehicle drove past you, you will notice a wind gush flapping on your face, on your body, and you will note that this wind energy is convertible, and this wind energy can be used to produce electricity. So in this paper we have designed a hybrid, not hybrid, but a design in which solar and wind energy was combined to get output and to produce electricity for highways. So the road power generation technology is such that we discussed earlier. What are the advantages of this technology? The advantages are that this will be 100% clean energy, it will be cost effective, it can power for 5 to 10 years and maybe even more if maintained properly. It is a sustainable form of energy, uses wasted wind currents of nearby vehicles, and it is a renewable energy source. So I'm gonna brief you into the research design of this prototype or the hardware system. So the first was the construction and selection of solar panel. So as you already know that we did this research, we noted the absolute temperatures and the different temperatures of the site. So the different temperatures were recorded, and accordingly a monocrystalline solar panel was chosen. There are different types of solar panels. There's monocrystalline solar panels, there are polycrystalline solar panels, and in a recent study there have been attempts to modify a solar panel to employ in rainy areas. So if there is more rain, you can employ a solar panel that will convert the water droplets and its power into electrical energy. So you can definitely check it out and use the best design according to your site. The next is the construction of wind turbine. Now the construction of the wind turbine for the solar wind energy tower is a little tricky. You have to I discussed a different paper, I wrote a different paper on it with my professor, and you can definitely check it out. We discussed numerous important design parameters that you need to learn just so you can construct your own wind turbine for this project. So my advice for you would be to read that paper and to learn more about it. But in a nutshell, let me tell you that we chose a two-blade Savonius rotor, and this two-blade Savonius rotor had had zero overlap ratio, and the aspect ratio was 1.25. You can check it out. You can definitely learn a lot more from that paper. The next up is the construction of inverter. Inverter is a device that converts DC or direct current into alternating current. The fourth up is the construction of charge controller. The charge controller is used to charge your battery, and you can definitely read more about it in the paper. I just have to brief you through this. Fifth up is the construction of a microcontroller, and as you may already know that we are employing a solar panel and a wind turbine collectively in our project. You may notice that how are we doing that, or you are already curious about it. So let me dig into that, the construction of microcontroller. So assume a scenario in which you placed this device, the figure 3, as you can see, this device on a road. So as you can see, when we placed this on the road at 9 a.m. the sun will be on its peak, and the output of the solar panel will be sent directly to the grid converted via the inverter, and the output of the wind turbine is stored in the battery. Why we are doing that is we want to generate, or we want to produce the maximum power that we can produce and use it to benefit our system. So we're going to sell it to the grid like a grid tied inverter. We're going to send output power to the grid, and we're going to use the wind turbine as our primary source in the battery. So if the weather is cloudy, the solar panel will not be able to extract any power from the sun, and hence a message will be sent to the grid notifying no power output per hour. This is done by the microcontroller. In the meantime, the wind turbine captures the gushes of the wind from nearby vehicles and will store its power into a battery. As you may already know that the vehicles are an important aspect or an important part of our daily routine. So vehicles cannot stop. Vehicles will always move, and hence the wind currents will always be produced no matter what. When it will be 6 p.m., the nearby street lights will be powered from all the wind energy collected in the 12 hours of its operation. Meanwhile, all the power output will also be stored in the battery and will be used, as you may have already known. As you can already see that no power is stored in the battery from the solar panel, because you cannot store two different types of power sources in a battery. If you want to check out, there is a reference to one of my teachers. He discussed it briefly, that how different types of sources can be integrated into a battery source, but his research is also ongoing. So at 6 a.m. all the remaining power of the battery is now sent to the grid for sale. This will benefit greatly to a grid tied system of solar wind powered devices. So if any one of you wants to check it out, you can read my paper. This is the hardware of the system. The figure 1, that is the inverter, the figure 2, that is the charge control, and figure 3 is the integrated solar and wind turbine system. As you can already see, the integrated solar wind turbine system has a solar panel placed directly on top of the wind turbine, and it will produce power output, and you can use it to benefit. These are the results that we obtained, or some of the results that we are sharing with you. Do read out our paper. You can definitely learn more about it, but the results are as follows: that when we measured the speed from an anemometer, we captured, or we read the following readings. It was 4.1 wind speed, and the voltages appeared on the multimeter were 14.91. Similarly, when a wind speed of 4.9 was generated, the power output or the voltage output was 18.17. And the results of the solar panel were as follows. At time 8 a.m. You had 10 voltages appearing on the charge controller, and when it was the peak hours, or 12 or 14, you can see a 19-hour average mean output was sent directly to the grid and for sale. And finally at 5 p.m. You can see a voltage of 14.62 appeared on the charge controller. So these renewable energy sources are basically the future. Renewable energy sources have to be employed everywhere for a clean, better and safe future. We cannot rely on fossil fuels for our generation, for our transmission. The best example is Elon Musk's Solar City project. Elon Musk, in his recent advancement, has argued that power cannot be made out of fossil fuels anymore. We have to form up a grid-tied system for our daily needs as well. Fossil fueled cars are no longer the future. EV cars or electric vehicles are the future. These advancements is pushing us to a better and safe future, and this safe future is going to enable smart cities. These smart cities are the future of human technology, and road power generation, let me remind you again, is the base of any smart city. My one of the paper is already on road power generation. You can definitely check it out. We converted the wasted kinetic energy of the vehicles into into electrical energy. You can read my paper on it as well. But these advancements are the future, and we have to move towards a better future for our children, for a sustainable life in this world. Solar wind energy tower can be employed at highly dense traffic areas as well. You can place it on highways, you can place it on busy roads, be it your choice. And this can also be integrated with a smart grid. So all your development goals, or the United Nations development goals that the UN always brags about, you are going to complete those goals if you employ a solar wind energy tower as well. And this also promotes sustainable development goals. Finally, these are the references. If any one of you wants to read the paper, it is available online on the conference. Thank you so much for your time. Till the next presentation, goodbye.